super, super, super important that you understand how this works. So we are using the definition of a derivative, so the limit definition of a derivative. Okay, we know we're finding a derivative because I see that f prime notation here. And what I want to do is figure out what my function is, what the derivative of that function is, and then I'm going to find the derivative at x equals 0 and x equals 1. So this is using Hannah, H-A-N-A-H's, because there's two H's. This is her method. And what that method looks like is this: the limit as h approaches 0 of f of x plus h minus f of x minus h over 2h. So this is the limit definition of a derivative. It's one of the three representations. And this is not a common one. I typically will use f of x plus h minus f of x over just 1h. But this also works. So just to remind you of how this works, this is just using 2 points. We've got x plus h, x minus h, and we've got x plus h, and we are calculating the slope between those 2 points. Now we want h to approach 0, because then we're going to have two very close numbers. We're going to have, like, if h is 0.01, this might be like 1 minus 0.01, so that'd be like 0.999. And then this one would be 1 plus 0.01, so that'd be 1.001. So if I used a 0.999 and 1.001, and I use those 2 points, that's really close together. So that's why we want our h value to be really small, is because it represents the distance between those 2 points, and we want those distances to be as small as possible. Now, if you calculate the slope between those 2 points, rise over run, so we're going from f of x plus h to f of x minus h, and then divided by x plus h minus x minus h. If you calculate the slope, okay, that's going to be f of x plus h, that's our first point, minus f of, and then the y coordinate of our second point, divided by x plus h minus x minus h. And the the x's cancel, and then you get h plus h, because h minus negative h is h plus h, which is 2h. So that's where that definition comes from. But now we need to match it up to find this information. So we have f of x plus h minus f of x minus h. So from here, you should be able to figure out, like, what am I plugging x plus h and x minus h into? And you can see what the functions are. It's going to be x squared minus 3. And then just double check. Like, I think it's x squared minus 3 because that's what I'm seeing here. I'm seeing something squared, and then I'm seeing minus 3, and then something squared minus 3. And then just plug in. Like, if I was finding f of x plus h, that would be something squared minus 3. That something would be x plus h. And hey, that's what I see there. So to find the function, just look at the numerator, and you should be able to see pretty clearly what that function is. In this case, you can see it in both the f of x plus h part and the f of x minus h part. The x is replaced with x plus h, or the x is replaced with x minus h, and then everything else stays the same. It's still squared, and it's still minus 3. Now f prime, now that I understand that this is the definition of a derivative, you can FOIL all this out and actually, like, do the subtraction and solve the limit the old way. Or, because you know the power rule, just find the derivative using the power rule. It's 2 times x. And then to find the derivative at x equals 0, that's going to be 2 times 0, which is 0. And to find the derivative at 1, you're going to plug in x equals 1, so we get 2. So what I want you to be able to do is, given the limit definition of a derivative, you should be able to follow these steps. You should be able to find f of x and then find f prime using the power rule. So you can expect to see this on an ESA or any other test for this class. You can expect to see a derivative given by the limit definition, and then you have to figure out what was the function, find the derivative from that function, and then you should be able to, like, plug in the numbers.